Howdy! This is your friendly neighborhood physics teacher here, and we're going to go through some of the Phet simulations you're going to do on Wednesday. And I'm just going to show you the Phet simulations you're going to be dealing with, and then another cool Phet simulation that it's just really cool to kind of talk about. So the first thing you're going to do is your bending light simulation. And so we're just going to see how light is affected with different materials. So we have air up here and we have water on here. If you sit here and turn on your ray, and we're dealing with light, you can sit here and move and see how remember this is your incident ray, and this would be your ray of reflection. And so it doesn't reflect all the way, right? Because it kind of goes into your liquid here, and so that would be your ray of refraction. And you have your incident angle, your reflected angle, and then your angle of refraction there. You can sit here and pull your what is this? I can't think what that's called all of a sudden. Lord have mercy. It's a Monday morning, isn't it today? You can pull out your protractor and see what angle everything is happening at. Just sit here and line that up. You can see that your angle of reflection, your angle of refraction, angle incident are the same, and then you can sit there and figure out what your angle of refraction is. Remember, it always goes off the dotted line here, which is your normal line. And you can also pull out your intensity and see how intense it is. So, your angle of incident, your incident ray is always going to be 100%. Your intensity dealing with according to what material you're going in will lessen. And then your how much it reflects, again, will affect on what material you're dealing with. And so just a couple of things to do that. You can just do a wave if you want, but I would just stick with the just normal ray, so you don't have to sit there. And how to change your materials, just go up here and you can change your materials. To change your your index of refraction, again, it's just how much your material is going to refract. That's all it is. It's just how the material is going to refract. So that's how you would do that. So we're going to scroll up here. You want to sit here and play with the prisms. You can put a prism and do that, and you can see how your refraction is going to happen there. You can do multiple rays. You can do a white light, and oh look, you're playing with. You can sit here and angle it and see what happens. It's only a certain angle. So if it goes, this is called an internal reflection. So it pretty much goes from rainbow back to white light if you do an internal reflection. But if you sit there and play with it and get back out, that's when it forms the rainbow part. And you can do with air, you can do with gas, solid. You can sit there and play with your environment and different prisms. You can play with what object you want you want it to be glass, water, and you can also see if you want to show all the different reflections that happens, because there's actually a lot of internal reflections that happen inside a prism. You can just see in all the different normal lines, and you can use a protractor if you need it. And again, you can change your index of refraction. That's basically you're just changing the object on how much it refracts or not. So you can also play with that one. You have this one that just has more tools to sit there if you need to sit there and just find speed and time and oh look, angles, but we're not going to make you do that. But this way you sit there and have fun to play with. So that is your bending light. You're going to mostly spend in this one and play a little bit into that one. You won't necessarily have to go into the more tools one, but you can if you want to go play. The next one we're going to deal with is the color vision Phet lab. You're going to start with your multiple lights, and you're going to see that, oh look, I'm seeing green. What if I add a little red to the mix? Oh no, I'm seeing yellow. You can see how it blends. You add a little blue to the mix, you're going to end up seeing white. And you're just sitting there blending the different colors and seeing what colors you get. You have your primary colors, or your main colors, red, green, and blue. Yes, these are your main colors dealing with physics. I know all my art people are like twitching right now, but these are your main colors. And then you do get your secondary colors when you blend two of them. So guess what? Yellow is a secondary color. Yes, yellow is a secondary color dealing with physics. Accept it. It's okay. Then you'll jump over just dealing with a single bulb. And so this is just dealing with your light bulb. And you can sit there and blend, like if you want to do different color bulbs, what happens, and putting different filters in the mix and seeing how that works. And so if we put a blue light, of course, there's no blue in red, but there is blue in, yep, so blue, of course, but there's also blue, should be a little blue in the cyan color, so the little blue does get through. And you can sit there and play with answer questions that way. Now, the third one I want to play with, there's no questions on this one. This one's just really, really cool. You actually did this version last week. We're going to talk about how light, and just waves in general, interact. So we're going to do it with interference. Oop, I already have funness going. Stop. I don't want funness going right now. Okay, I'm going to put you off to the side. So right now, we have two different laser pointers. And we're just going to pick a random light here. So we have two different laser pointers going. And again, light radiates out. And you can see as light gets further and further away from the starting point, it does dissipate. Now, it doesn't dissipate that much like it's showing, because light can go a whole lot further, but we're going to pretend like this is like the vast, huge thing. So light actually doesn't dissipate as much as it's showing right now, but it's a simulation for us to see how things interact. If we add a second light to the mix, you're going to get interference. So this is like when we talked about with the string, when we had conversion and divergent interference. Conversion is when it gets, so think about in sound, it's like when it gets louder. In light, it's when it gets brighter. And so these are your little spots here that you actually see the green. And so they're helping each other. They're getting bigger. Your wavelengths are getting bigger. Right, not your wavelength, your amplitude's getting bigger. These areas that you're seeing no light, they're actually counteracting each other, canceling each other out. So your amplitude's getting smaller, and that's you having your divergent interference. So convergent is when they're building on top of, divergent is when they're going away. And so you can actually see that light, sound interact the exact same way, they just, versus seeing versus hearing. Now, if we add kind of like a slit. And we talked about refraction, not refraction. There's too many R's in this unit, just saying there's reflection, there's rarefaction that deals with sound, and then there's we're talking about, and there's divergent, convergent, there's reflection, refraction. So the refraction is when light bends, and then you have diffraction, which light does bend, but it bends around a barrier, which you'll see here. And you can remember that this is the diffraction part because it makes a D. Look, there's little D's everywhere, not big D's. And so light literally bends around barriers. And so even though it's going in a straight line, this energy is all being forced, and it kind of bends out. And the same thing, sound, anything does that. Now, when we add two slits here, this is called the double slit experiment. This is how they decided, which we'll get into our next unit in dealing with nuclear, how light is a particle and energy. Light has dual, kind of like, so you have like dual citizenship. Light has dual nature. It's energy, but it's also a tangible thing. And they realized that using this double slit experiment. And I'll put a video in talking about the double slit experiment. It's really cool. And it's just seeing how light bends and interacts, seeing that it's a particle and energy. And light's just special like that. You can see how it's still moving around, but you still have this convergent, divergent issues happening here. And another thing you can look at for divergent is, see if it's sitting there going through a hole, it focuses in the center and then kind of lessens as it goes out, and it makes the shape. The light forms the shape. That's why you're able to sit there and do like shadow puppets. Light will go around the shape you produce it. So this is a square and a light. Multiple different things. You can see how it starts, a little bit of interference there, converging, diverging, brighter, lessening, and even going around a human, and how light bends around different things. So that's kind of cool, dealing with some, we in the notes, you saw things about reflection and refraction, but you didn't really see any diffraction. And so I wanted to show the diffraction using the Phet lab. So that's about it for the Phet labs. I hope you have a wonderful day. Bye.